Thank you very much, Robin. Good day, everyone. And again, thank you guys for continuing our consolidations track in the 2021 Hyperion Solutions Conference. I am Terrance Walker, InterRel's Consolidations Practice Director, here to present just when you thought that FCC performance couldn't get any better, then came the Dense Sparse Optimization. But first, a bit about InterRel Argano. I'm sorry, ArganoInterRel, forgive me. We are the 5-time EPM and Analytics Partner of the Year. We have a number of recognized experts who are part of Oracle's ACE program. We also have received a number of commendations from Oracle. Given that we're the 2019 Oracle Analytics Partner of the Year, we were also the 2019 Oracle Global and North American Partner of the Year. We've also been the 9-time Inc. 5,000 fastest growing companies, one of those companies from a commendation perspective. We have received a number of different partnerships, and to be quite frank, we have the most experienced resources within our practice, which promotes success from a corporate perspective. The Net Promoter Score is a measure of how likely a customer is to recommend a brand, a product, or a service to a friend or a colleague. The industry average for systems integrators is 24, and for global systems integrators, the average is 9. ArganoInterRel's Net Promoter Score is 77, which is indicative of our client satisfaction and the relationships that we form with our clients. World class, yes, world class is simply our expectation. And every day we hold ourselves to this standard of excellence. It's our commitment to excellence that distinguishes ArganoInterRel from our competition. We're committed to building digital foundations that improve operating efficiency, agility, and effectiveness to not only propel our customers to enable them to become industry leaders. We are ArganoInterRel. We'll quickly jump into today's session, but again, today's session is much more indicative of performance improvements that Oracle's made over the last few months as a means of better improving performance in FCC. The first feature that we'll speak to will be the control to date storage option. The control to date storage option was first deployed in July of 2021. Again, for those applications that do not leverage the control to date storage option, quite simply the consolidations and translation rules populate or calculate values for each of the view mentioned members, including the quarter to date member, half year to date if it's enabled in the application, and the year to date member from consolidations and translations process. Quite simply, each time consolidations is run, the actual value stored for each of those differing view members. And no, we do not store values in the year-to-date input member. It's simply a bypass or throughput fashion for us to integrate data on a year-to-date basis into FCC. But for those applications that elect to be created with control to date or enable for control to date, there is an option, better yet, to determine which of the to date view members we will be storing data in the application, which simply promotes small application sizing, much faster restructuring times, as well as, and most importantly, much faster consolidation performance. As I mentioned earlier, there are two different fashions for enabling control to date, either via the initial application creation, or secondarily for existing applications via the application's feature enablement module. We can enable the control to date storage option in FCC. But again, there are certain considerations that will definitely, or better yet, that should definitely be taken into consideration with that pivot for pre-existing applications. That said, for newly created applications, as we're reflecting, via the application creation wizard or the features enablement, there is an option to enable, as I mentioned, the control to date view storage. But please be mindful. If we are electing to enable the application to make the period and dense dimensions dense that the control to date view storage is not a available enablement, because as a byproduct of the make period and moving dimensions dense, control to date view is a defaulted enable feature in the application, which again promotes much smaller applications and far better consolidation performance in the application. Now, when we speak to the actual control to date view storage content, we'll note that with the advent of enabling this feature, we'll note that there are 4 additional rules that are available to us from a consolidations and translations perspective, in that for each of the console and force for features, as well as the trans and force trans features, there is an option to select a view in concert with that consolidations or translations process. Also be mindful that in this process as well, when we're actually running the actual consolidations translations, we can also select by default the periodic member or also other view dimension members to populate data. Also be mindful from an advisory perspective, when we elect to only run consolidations and translations by selected view for only the periodic view, we're simply going to find that the application quote unquote deletes the values in the to date views in the application. But there are some additional views in the application that we can actually leverage to be able to visualize data in FCC. And again, those are part of the view system members for year-to-date, half-year-to-date, and quarter-to-date rules. But in my reality, I've learned that since the year-to-date, half-year-to-date, and quarter-to-date members are all dynamically calculated, and because the year-to-date through quarter-to-date view members and the system members for year-to-date through quarter-to-date all simply leverage the exact same member formulas, there isn't necessarily a need to ever reference the system view members, because those same valuations are populating on a dynamic basis in the year-to-date, half-year-to-date, and quarter-to-date members themselves. You'll also note from the rules card that those 4 rules are now available to be run from within the actual rules card themselves. And again, when we elect to launch either of these rules, the common rules wizard is available to us from a selection perspective. But you'll also note that for the consolidate by selected view, there is an additional runtime prompt for populating the view dimension. You'll also note that the periodic member, which is again the default member and which should be run each time, is pre-populated within the actual view within the wizard itself. We also have the wherewithal from a member selection perspective to select additional view dimension members to be part of the control to date consolidation process on a view basis that we can run. Once we've selected the appropriate views for running consolidation for the corresponding point of view, we can then elect to launch this rule to consolidate for the corresponding defined intersections that we define in our runtime prompt for the consolidate by selected view option. Very straightforward premise. Again, the thought process here is that we are simply impacting the application's size to be able to have much more optimal performance from a calculation perspective or consolidate and translation perspective as it relates to these 4 rules themselves. From a control to date feature enablement perspective, as I mentioned earlier, we simply would access the configuration functionality set of FCC and enable features in the application and opt to enable the control to date view storage. Now, our reality also is, because we're electing to literally delete data from corresponding periods within the approval unit, I guess we'll say, there may be a need for historical periods, depending on if you're actually leveraging the locking and unlocking premise within FCC. There may be a need to go back to historical periods and to unlock historical years and rerun consolidations to right size the application from a literal resourcing perspective. But now also be mindful that if we're going to go down a path of impacting historical periods, and again, the thought is that we would simply store periodic data for those historical periods when necessary, if we wanted to do some form of analytics or reporting, we simply select the to-date view member for that level of reporting, which would by product have a direct impact on the application size. Now, also as a byproduct of going back and reconsolidating historical periods, and in effect deleting stored to-date view data, there'd also be a need to run the clear empty blocks rule for each of those years or historical years to make certain that from a little application perspective we are doing our full housekeeping on the historical years in our application. And also as a strong advisement to also run a restructure of the cube after having run the clear empty blocks in the application for historical period consolidations. Next, we'll quickly shift to the dense sparse optimization, or literally the reason for the season. You'll find that I'm going to use dense sparse optimization, or DSO, and make period and movement dense interchangeably, because from my perspective it's DSO, but from a literal application tier perspective it's make period and movement dense. As was the case for the control date view option, we found that the DSO functionality was made available to us soon after in the August release of FCC. And just as was the case for the control to date view options, we can also elect to impact the application in different fashions. The first being that if we're creating a new application, by default, the make period and movement dense is a default option in the application. If we elected to not include those two as the dense dimensions in applications, we simply deselect that option on application creation. Or for pre-existing applications, we can opt to run the migration utility to transition application to leveraging period and movement as the dense dimensions in the application. A couple of additional considerations from a migration or transitional perspective is that the system-defined members in the application are actually impacted as a byproduct of the migration utility actually running. But any custom logic that might have been created in the application will not be impacted with the migration utility, such that any custom calculations, any insertion point rules, more specifically, any on-demand rules, or any member formulas, those rules may require some level of revisit depending on the fashion that would have been developed. Meaning, if you may have fixed on a dimension that's been transitioned from being sparse to dense, or vice versa for the count dimension, there might be a need to go back and review the literal definitions from a calculation perspective to ensure that you're following leading practice based on the transition to the period and moving dimensions being dense. As I mentioned earlier, from an application creation perspective, the make period and dense movement dense are default definitions from an application perspective. That is a feature enablement that can be enabled or disabled. Again, for those who have a desire to still have the count dimension be dense, have your way. But our reality is, from a deployment perspective, we found that the literal application administration has been much more proficient, given that when we're talking about the period and movement dimensions, those two dimensions are not the most fluid dimensions in the application, as might be the case for the account dimension, because from an application ownership perspective, we found that the account dimension is often impacted on a daily basis, and in many cases impacted multiple times per day, such that each time, depending on the application size, volume of historical data in the application, the duration of database refreshes may be more elongated. The duration of restructuring the actual cube may be elongated simply because the account dimension would be the dimension in application. Well, conversely, we found that with the transition to making the period and moving dimension the dense dimensions, those two areas of application administration have been much greatly improved from a duration perspective. So again, great win, and big thanks to Oracle for the transition, because It's been a huge win for us as far as right sizing applications that have high volumes of data and also have some fairly high level customization to help improve the application's performance. We're going to transition now to actually walk you through the actual migration process as we transition from having an account dimension being dense to simply having the period and movement dimensions as the dense dimensions in the application. So from a pre-migration perspective, we want to first ensure that the application is enabled as a hybrid application. Once we confirm that definition, we want to make certain also in our pre-migration steps to confirm that there are no metadata validation errors. Again, these can be the most pervasive in application administration. If there are different property definitions that are deviations from expectation or default behaviors in FCC, we want to make sure that we address those errors or warnings, what have you, prior to invoking this migration utility. We also want to make certain that there are no pending metadata updates in the application. Again, that just speaks to any pushes from products like the Enterprise Data Management Utility or any native metadata updates in the application, or even anyone who's leveraging SmartView for metadata administration, any pushes of metadata update for additional members, hierarchical changes or member property updates from the SmartView application as well. We want to make sure that there are no pending metadata updates there as well. And then lastly, we want to make certain that we are able to successfully refresh the database prior to invoking the migration utility. Again, be mindful that in this case, the database refresh is going to be indicative of a dense account dimension, so maybe a little bit more elongated than will be the case post-migration. We'll also make note that prior to that transition, as I mentioned just seconds ago, that the account dimension would still be dense, so we can actually see this reflection in the simplified dimension editor, where it's actually noting that the only dimension in the application pre-migration would be the only dense dimension, in the application would be the account dimension itself. Also, from a pre-migration perspective, we want to make certain that before we invoke the actual utility that we want to take post database refresh, a snapshot of our environment just in case. I think you get my point from that perspective. So again, we want to take a snapshot of our environment and all the underlying components or artifacts in the application or that application's environment. And then we want to make certain that we disable any scheduled jobs. Very important as a means of validating the process and ensuring a successful application migration. And then lastly, if there are any, I'll say in a different fashion, we'll need to amend or reschedule the automatic maintenance window or the AMW, because if we do not perform that update or rescheduling, there may be an impact on the success or the validation of the migration within the application's migration utility. Once we've gone through and performed that specific level of thought or preparation from a migration perspective, we can actually kick it off. And again, where do we access this utility? The utility is actually available from the application overview feature set under the actions menu. For those who are intimately aware or familiar with FCC, we quite often validate metadata and refresh the database, but also as a one-time action, we would make the period and movement dimensions dense in the application. Once we've selected that action to move forward in that process, we'll then see the corresponding checklist that exists in the application as a pre-migration validation opportunity to ensure that the previously mentioned actions have been performed as a means of preparing for this transition. Again, since it's a predefined utility, the little definitions are done behind the scenes, fairly limited responsibility from an application administrative perspective, other than to ensure that the pre-migration checklist items or the housekeeping items prior to migration have been performed prior to the migration has been kicked off. Also, as I mentioned earlier, one thing to be very, very mindful of is I've actually encountered this myself, so I thought it might be pertinent to speak to this from a conversational perspective, is that if the automatic maintenance window is within 12 hours, then this process will not start. So you'll need to either perform this action prior to 12 hours from the kickoff of your automatic maintenance window, or you need to go in and reschedule the automatic maintenance window to ensure that from a validation perspective, you can move forward in the migration process itself. Once we've confirmed each of the checklist items, we would then transition to the validation process or the validation step. And again, this is where the underlying migration utility content is validating that prior to kicking off, we perform all other required steps to be able to successfully kick off the the migration of the application. Once we've done that, you'll notice that there's actually some form of additional warning just to ensure that you do want to kick off this process, and also be mindful that throughout the migration of the application, there is certain logging that's included to give visibility into the state and or the status of the migration as well. So once we confirm from a warning perspective that we do want to migrate the application, the migration process actually kicks off. And as was the case from a validation perspective, there's also some form of a notification of the state or status from a migration perspective as well. Now we're talking about the actual status of the migration. As I mentioned, there is specific logging, and the logging is much truer to what specific artifacts are being impacted at a dimensional level. We'll note here that we're noticing where corresponding member properties are being transitioned as a byproduct of the migration. We'll also note that from an underlying perspective at the lower component of the logging, it's still just speaking to what's being performed, and from an on-demand rules perspective, there may be a need to go out and perform some level of review. That also should be extended to include our insertion point rules and also member formulas as well. As far as a more holistic view of the logging, once the actual process is completed, you'll note that the actual logging speaks to each of the dimensions that would have been impacted as part of the actual migration process itself. So again, we'll have a more holistic view of those dimensions that would have been impacted by member property change or even some form of reordering in the application for each of these dimensions as you're circling through the actual content in the application migration. Let's see if we can answer questions in real time, since this is a very, very long presentation. The first question is it too complex to ask, how does DSO make an application faster? The biggest reality from my perspective as far as how DSO makes the application faster is that the volume of stored content application is compressed. Since we've transitioned the account dimension from being a dense dimension to being sparse, I found the calculations run faster. I found that database refreshes are performed in a faster fashion. I found that database restructures are completed in a faster fashion. So that is my reference to how DSO impacts the application from a performance perspective. Okay. I hope I answered your question regarding how and why we found that DSO actually impacts the application. But again, there are certain applications that perform well prior to DSO, so there may not be a need to transition to DSO. It's simply a consideration that we've taken into account for applications that were fairly large in size, and we knew that we can get better performance as a result of this transition. Also, as part of the status tracking for the DSO conversion, there's also a job with a corresponding log file that I just displayed that we can download to review the state and the status of the actual process. You'll also note that, excuse me, in this example, the actual duration of the migration to DSO took just around 38 minutes. Now, from a tracking perspective, in the migrations that we perform for our clients, that durations has ranged anywhere from 25 minutes to just under an hour, and that's much more indicative of the application size, which also in some fashions also is representative of the volume of historical data in the application, which has direct impact on the duration of that migration. So again, if you're talking averaging, the migration process takes 30 to 40 minutes maybe in process, given that it's a one-time action operation in the transition or migration. Also, once the actual process is done, as is the case in most Oracle applications, there is some form of a confirmation that the application's migration has been completed. Also note that the person who kicked off the migration is going to have to log off and log back in again just to realize the advent of their migration of the application. And again, for all intents and purposes, the migration process requires no true action from the person invoking the migrations process, simply to make certain that from a housekeeping perspective, pre-migration, that certain activities are performed. We'll then make note that from a little visual perspective that via the application's dimensionality, you'll note that the movement and the period dimensions are now the only dense dimensions in the application. And then from an evaluation order perspective, we're noting that the count dimension is now, or better yet, does now have an evaluation order of 1 as far as the bit being the first sparse dimension in the application itself. Couple of things to also be mindful of from a housekeeping perspective. I cannot say this enough because this is one of the areas that we had to focus on the most in some of our applications that have the most or the highest volume of customizations. Please make it a point to review your member formulas and your search report rules and also your on-demand rules because the data validation process, once we've actually completed this migration process, is going to be very, very important. We want to make certain that the actual output from our calculations is actually populating. We actually found in some cases where the actual solve order value was going to be important for our member formulas, and also a necessity to go out and impact the actual syntax definitions in our insertion in our on-demand rules. Got another question. I'm going to answer these in real time. The question is, does DSO mean that we can now write calc scripts for the movement dimension since it's now dense? Before, it could easily impact performance. I think that, and I'll confirm Klaus's this answer, I think that the answer is kind of yes. But again, I'm very, very mindful of how I'm writing rules on dense dimensions. Again, the thought is that I would if on a movement member so I can actually populate data to a movement member where necessary. But I do believe that this does open up a new opportunity for us. But for whatever reason, I'm thinking prior to migrating to DSO, I believe that I went out of my way to avoid calculating on movement members, even though I could. But I know that one of our realities is, let me say it in a different fashion, Klaus. One of our biggest areas of focus was, and this may have just been a Terrance thing, I know that when I used the create block, I would normally create block on a movement member since it was a sparse member. So that actually required that for those applications that I migrated from pre-DSO to being DSO, or maybe a non-DSO to being DSO, I'd have to go back in and to amend those calculations where I was leveraging a movement member for my block creation, where I can now transition that to using the count. So the thought is that you should be able to create calcs on movement members, but maybe in a different fashion from a syntactical perspective. And I hope that answers your question, sir. Also, as I mentioned, from a solve order perspective, again, this is a much more of a lesson learned than a true housekeeping item. You want to make certain that you'll note that any pre-existing parent account members that were in the application prior to the migration of the application to period and movement being dense, those members will now have a solve order of 58. But please remember that if you're using some automated fashion for managing master data with EDM, or if you're manual shop where you're managing metadata manually, You want to make certain that as you're adding new parent accounts in the application, you'll want to ensure that you are defining a solve order of 58. I think I forgot to include a screenshot on this in my presentation, but I think I'll include that in the presentation that we'll send to those who want to review the content. The means for impacting the solve order in FCC via the simplified dimension editor is fairly straightforward, given that from the ribbon, the member property ribbon on the account dimension, there is a right-click option. You can scroll down to deselect the default mode. Once the default mode is disabled, we then have an opportunity to scroll over to see all of the hidden member properties for the account dimension, and you'll note that the solve order is there for update the corresponding account members there. And also, not just the parent member solve order needing to be updated, but also we found that we needed to define a solve order 58 for accounts that included a member formula as well. And again, in our world, we try to create applications or develop applications from a spirit of simplicity. And in many cases, we can create member formulas to circumvent the need of populating a value or some level of syntax or scripting in our differing insertion point rules. So we do leverage member formulas where applicable or where necessary. But again, this is definitely going to be an action that you have to be mindful of in your migration process. And then also, for those of you who may have some saved data exports, since the account dimension will no longer be the only dense dimension in the application, you will need to recreate those export jobs, being mindful that the movement and the peer dimensions are now the dense dimensions in the application. Also, we're talking about the movement and the data source dimension. We want to make certain also that all parent movement members are now dynamically calculated. I think that this should have been the case before. Again, given that the movement dimension was a sparse dimension prior, I can't think of a scenario. There may be some, but I haven't found from within my practice where we've actually developed any movement hierarchies where the parent members were not dynamically calculated. But again, as an advisory, these will need to be defined as dynamic calc on a go forward. The migration utility will pivot these to all being dynamically calculated for members that existed prior to the migration. And also, from a solve order perspective for both the movement and the data source dimensions, you'll want to remove any solve order references from members in your application from a housekeeping perspective. Next, we'll transition to speaking to metadata revisions as a byproduct of the DSO migration. We'll first speak to the view dimension. Now, the view dimension, as I spoke to earlier, is a dimension that it will be impacted by the control to date storage functionality. And from that perspective, you'll note that the transition here pre to post migration is that the year to date, half year to date, and quarter to date members are now dynamically calculated members. And as I mentioned earlier, they do share the same member formula logic as the view system members have as well. Hence, I found no need to ever reference the system view members with the rule suffix because the exact same valuations are populated in the standard view dimension members or the standard to date view dimension members that are part of my standard view hierarchy themselves. And also, just to make sure we're clear, that the only true dimensions that are members in this dimension that are truly submission members are the periodic member as well as the year-to-date input member from a submission perspective. But our reality is once data is submitted into the year-to-date input member, data is automatically calculated, populated from a periodic, half year-to-date, quarter-to-date, and year-to-date perspective in the application because there's no true visualization of data at year-to-date input post data submission. Again, here's a view of one of the member formula definitions. I believe this is for the year-to-date calculation, just so that how the actual member formulas or the scripting or coding definition is defined for those shared member formula definitions for the standard member for year-to-date, as well as for the to-date members with the rule suffix in the application themselves. We'll next transition to the movement dimension. And again, as I mentioned a few moments ago, that all of the seeded members are the seeded members that include an FCCS underscore prefix from a parent member perspective would have all been transitioned to being dynamically calculated, and to remember to ensure that any subsequently created parent level members in the movement dimension should also have a dynamic calculation data storage. And also remember that this is now a dense dimension. Similar premise from a period perspective. No true movement here. The period as it would have been defined in application creation is going to be consistent. The only transition here is that, you guessed it, just as was the case for the movement dimension, the period dimension is now a dense dimension. And then from a data source perspective, now the data source dimension pre-migration actually included a system types hierarchy that included members that are no longer prevalent post-migration, including the override amount member and the override rate member, as well as the pecan member from a little member definitional perspective. Post-migration, that actual hierarchy only includes the driver source member, but also be mindful that, given that from an override perspective, depending on your fashion for submitting overrides via the override form or submitting overrides on an ad hoc basis, the rate override and the amount override members actually exist in the consolidation dimension. So there might be a need to reference any smart view reports that you had for submitting the corresponding override amounts, where you may have elected or opted to reference any members in the system types for amount override or rate override from an ad hoc perspective. Don't know if that was something that we did before, because historically I would use a form for submitting overrides, but if there were ad hoc submissions that were based on leveraging those system members, there might be a need to go back and revisit those ad hoc reports as well. As I wrap up, just a little bit of information for some of the results that we've encountered or experienced since we've gone on a path of implementing DSO for our FCC applications. One bit of reference is that simply the application sizes have greatly diminished. Now, one of the things that we're very mindful of from a change management perspective as far as what our core expectation is for application sizing. We found that prior to DSO, we had some really large applications from our perspective. And it's kind of funny, having surfed the industry. I've actually talked to differing partners who have applications pre-DSO that have applications that were over 100 gigs. It's like, Jesus. Again, that 100 gig application probably had consolidations that took 35, 45 an hour per period, which in my mind is insanity. But for others, it may be acceptable. So again, it depends on the threshold of acceptability or acceptance that might drive what may be considered to be acceptable versus non-acceptable from an application perspective. But in this case, we found that when we transitioned this application from being non-DSO to being DSO, we found that the index and the page file sizes decreased quite significantly, as well as block sizing, existing blocks, what have you. We found that there is much greater, much more expected valuations from a member property perspective or statistics than that we found pre-DSO. Again, we live with it, but again, now that we know better, we do better. Now here's no more than a graphical view of some of the applications that we've actually migrated from being non-DSO to DSO, with some corresponding statistics on those Apple applications. From left to right, we'll note that there are differing volumes of data as far as historical periods. You'll note that from a little index and page files perspective, we saw that those values greatly decreased with the advent of the migrating the applications to DSO. Also, from a database sizing perspective, we found that applications truly decreased from a sizing perspective, which actually, from our perspective, actually helped us in the application migration process. Traditionally, we use copy snapshot from instance with EPM Automate. We've since transitioned to cloning applications across environments. And because the actual applications are much smaller, we found that our ability to be more nimble and migrating applications across pods has been much more expeditious than prior to the advent of DSO. And then lastly, on the far right, we have some actual real references to the actual consolidation times, where you've seen consolidation times go from 90 minutes down to 12 minutes for fairly large applications with lots of historical data. Also seen applications go from 12 to about 3-minute consolidations per period. Now again, this is not for everyone, because I actually have a non-DSO client who I can consolidate data in less than 45 seconds on a monthly basis. And what's actually really hilarious about this is this application has a very high volume of custom or insertion point rules, and this application works like a whiz. Now again, that may have a lot to do with how we've crafted the metadata from a definitional perspective, but again, every application isn't necessarily ripe for this transition, but in a number of cases, we found that in our testing and on a comparative basis, the performance of applications post DSO versus applications that were not converted to DSO has been much better and much more to our liking than prior to. As I wrap up, a few observations. Again, we found that from a database restructuring perspective, we found that the actual timings for those restructures has been reduced by about 30%. We've also found that the database refreshing times have reduced quite tangibly, reduced by about 45% as a byproduct of the DSO migration. We've also found, though, that with the transition to DSO, for those applications that are enabled for ownership management, that as a result of refreshing the database, there will be a need to recompute rates. We found that that actual recompute rates time has increased about 20% with the transition to having the period and movement dimensions being dense dimensions. So that's the one caveat that we found from an application administration perspective, is that the recompute rates rule has taken a little bit longer than it did before in the invoking of DSO. But we find ourselves refreshing the database far less frequently than we do find ourselves consolidating data. So from that perspective, it's a win that our consolidation times are much faster because of this transition versus having to have a little bit of a scant uptick in the duration of our recompute rates rule. Also be very, very mindful. Again, I hate to be Mr. Redundant Man, but please be mindful that because of the transition from a dimensional perspective, you want to make sure you revisit the scripting definitions for your insertion, on demand, and your memo formulas in your application. You'll also want to make sure that you're being mindful that for accounts that have member formulas, that you'll need to amend the solve order for these accounts that are dynamically calculated from 0 to 58, as well as for your parent members in your account dimension. Make certain that for newly added members, they have a solve order 58 as well. And then lastly, this was interesting because I've seen different implementations or differing behaviors for data management. Prior to DSO, we had some difficulties, we'll say, in leveraging data management to export data or to integrate data from FCC into Planning Cloud. After having transitioned the application to leverage DSO, this actually resolved that issue. Again, it may have more to do with transitioning the account dimension from being dense to sparse, but that actual issue was no longer prevalent in our integration, so we didn't have any issues or instances where we weren't able to integrate the exact data integration or data intersections that we want to move from FCC to planning. So again, this was a great win for us. Also, in addressing a roadmap item for Oracle as far as making certain features and functionalities available to us within data management. With that, that brings us to the end of our session. Again, I want to say thank you for attending today's session. Just when you thought that FCC performance couldn't get any better, then came DSO. Again, my name is Terrance Walker. Again, I want to thank you guys for attending today's session, and I hope that you guys continue and attending the Differing Solutions Conference sessions. With that, I'll bid you guys a fond adieu. Have an absolute grand day,